In this video, we're going to talk about local extrema. So when you're hiking, it's often interesting to know when you're at the highest part of your hike, when you're at the lowest, right? If you're kind of doing this hike, you go up some hills and down some hills and stuff. It's kind of important to know, like, oh, I've gotten to the point where I'm about to go downhill. All right, that would be like here. All right, you're at the top and you want to go downhill. The next part's going to be a little bit easier. When you know you're at the bottom, you're going uphill. You know the next part's going to be a little bit harder. So knowing these peaks and valleys is important. And we're going to look at the same thing with functions. All right, so here's the formal definition. All right, if we have some function, all right, we have a local maximum. So local will be important for right now. It's our only type of maximum, but it'll be important later. Local maximum at x equals c. If f of c, so when I plug in c, is bigger than f of x for all the x near c. So if I think about, I have c here, I have f of c up there. It needs to be bigger. The function value needs to be bigger, so higher than everything else around it. So you can kind of see it's going to be this peak of this hill here. That's going to be our local maximums because it's bigger than everything else around it. And then for local minimum, it's the same thing, but now f of c is less than all those function values. So if I have c and my function value, that's down there, I need everything else around it to be higher. All right, so something like that. And you can see it's kind of the bottom of those valleys is going to be my local minimum. But together we call these local extrema. So extreme just means like kind of the farthest out things. All right, so local extrema just means there's highest and lowest points. All right, so we're going to identify the local extrema for the following graph. Again, we're just looking for hills and valleys. So we have a hill here and a valley there. All right, so we have a local max at the point. I'm just going to round a bit and say it's -2, -2.4. It's actually like -1.84, it's just easier to write. And we have a local min, right, that lowest point at 1.1. Again, a little rounding, but close enough. 1.1 is our local min. All right, so knowing that when you have a peak, that's going to be a local max. When you have a valley like that, that's going to be a local min. All right, so one more example, and just to kind of, this example is important to show that you can have multiple local mins and maxes. So every single hill is a local min, every single valley is a local max. We have these two local maxes. There's one at 1.5 and another one at 5.7. And then for local mins, we have this valley here and this valley here. So we have a local min at 3.1 and 7.3. All right, so you can have multiple of these things. That is kind of something important to remember. We'll look at a different type of extrema later where we can't have multiples, but for now you can get a bunch of other ones. And notice these are the only ones, even though this is like a high point, it keeps going up their way forever. So it's not an actual hill. Same thing, this is kind of a low point on the picture, but it keeps going down. So it's not an actual like valley there. All right, we're looking for these actual turns that happen to get local maxes and mins. All right, so here's one for you to do on your own. Identify the local extrema for this graph. I'll show you the answer in 3, 2, 1. Right, and our local max is there, our local min is there. All right, so -2, 1 is a local max, 2, -1 is a local min. All right, similar to increasing and decreasing, which we already discussed. All right, right now we can just do this by looking at this graph and kind of identifying the local max and mins. All right, but we're going to learn how to do this with an expression and using our calculus tools soon. All right, so here's the important parts. If we ever have a kind of peak of a mountain, that point at the very top is the local max. If we have a valley that dips down, that bottom point is local min. And you can have multiple for a single function. So if I just draw kind of a random curve, I can have a bunch of different local maxes and a bunch of different local mins.